Okay, I'll just go through this board with you, just some of the basics. Sorry about the mess. So this is what the normal board looks like, and you can see it's got all these little micro switches on it, and the keys press on the micro switches. So in your case, instead of the micro switches, I've got a pair of wires soldered to each of the lower rows. So you've got 14 notes. The upper ones are the sharps and flats, and we're not going to bother with them. So basically I've just put clipped cable ties around them, but as you can see, the ends here you can solder on your own switch, and basically when you press it, it joins them together, the two wires. So you've got pairs of wires and they're twisted. The colours don't mean anything. You probably have to label them or something. So you can shorten these and run them out to the row of switches that you're choosing to use. I'll just quickly go through what everything is. So this is the socket, the MIDI out socket. You might plug in one of those MIDI transmitters into there. This is a MIDI in socket, and we don't have any, that's not actually functioning at the moment. All the hardware on the board here is present, so we could, for in the future, attach some sort of pedal, for example. This is the computer here, and you can see there's just a standard cable plugged into there. You see that is a panel mount USB socket, so, and it's one of the kind of ones that you get on the back of a printer, so it's more sturdy. So I usually have a cable with a 90-degree angle plug in it, which plugs in there, because these are on the left hand end of my Gerdes, but that just plugs in and it's panel mount, so that solves you the problem there. This is a gaming button. It's you can configure it to do anything you want in the menus, but by default, it's when you press it, it simulates cranking. So you can basically just practice with your left hand. Press it again, and it goes back to normal cranking mode. This is a potentiometer. So you have a push fit knob which goes on there, and as you turn that, it adjusts the sensitivity of the crank in terms of when the buzz appears. Now in the case of an Organistrum, I don't think they had a buzz, did they? But anyway, it's there should you wish to use it. What are these? You've got two other ribbon cables. This one, I'll come back to it in a minute, connects to this thing. That looks like an electric motor, but it's not an electric motor. It's a rotation encoder. So as you turn this, it's spewing out pulses of data, telling the computer how fast it's going round. And then this last one, I haven't put the correct plug on the end yet, but that plugs into this board, which is commercially available. See, there's a row of pins there. It'll plug into there. And on that, there is a headphone socket. And I usually use an extender from that socket to a panel mount headphone socket. But if you mounted this in a clever way inside your enclosure with a hole there, then the people could plug their headphones straight into that socket. This has an SD card, a micro SD card on it, right, and on that are all the audio files, the WAV files recorded, and there's one for each possible note that the device might ever be required to play. It has to be said, the really low ones have been altered using Audacity from higher notes, and the pitch has been shifted down, because recordings of the ultra low notes don't actually exist from hurdy-gurdies. So the really high and the really low notes are kind of cheated. They've been pitch shifted down from recorded notes. So that's that. You only need that if you want to just have the headphone option. It's quite expensive board from the US, and I mean, it's for convenience. It will play 6 channels simultaneously, turning them on and off with minimum lag time, which is what you need for a musical instrument. So it's not just like the sort of board you'd have in like a music player, which just be one channel, and you don't really care if there's a few microseconds delay. with the track starting or ending, and it's playing high quality WAV files. So that's optional. Most people, 99% since I introduced that, 99% of people who order a hurdy-gurdy order it with one of those fitted. But originally the plan was that it would put out MIDI via the USB cable to something like an iPad or an attached PC, and it would also draw its power from the attached device, so it doesn't have to have a battery compartment. That was one of the reasons for it. So if you were running with headphones and you want to walk around with it and have it kind of self-powered, what I do with the hurdy-gurdies, as you've probably seen, is I put in a tiny power bank. It's like a really cheap version of one of these, and it's cylindrical, mobile phone power bank. And I supply a tiny link cable which goes from the power bank in a U into that, which of course is in the end of the hurdy-gurdy. So that, and then we just use in that situation, you just use the USB cable to power everything. You're not using it for any kind of data. So I think that covers all of that. Now the screen's a bit weird. It turns out through the design of this computer that you can use software to turn the power on and off to this memory card socket, which we don't use. We don't have a memory card in there. So what we can do using a special gadget, this thing, it's for debugging really, and you can get them from China, and basically it's an SD card sniffer. If you plug that into there, and I won't shove it in now, but it's a tight fit, it goes in there, ends in this row of 7 female pin sockets. You can plug the display directly into that, and what we do is we run this OLED display from that socket. Stops us running out of pins. Let's just move my light. Stops us running out of pins as much as anything else. So we don't use this SD socket on here at all. That's just excess to requirements. Okay, so the screen just plugs in, and there's also plug this end as well. Yeah, so that's that. And then I laser cut on my laser cutter these acrylic screen covers. So basically the holes match. So using, I think they're M2.5, so that's metric bolts through a thin panel of plywood. You'd bolt that up. Don't do the bolts up tightly though, you can crack the glass. You put that over the top to protect it. And then because the bolts have only been done up loosely, I put a dob of glue on the back of each nut to stop it coming undone. And I use a kind of rubberized glue, this stuff. It's like a cross between a latexy type glue and a normal sort of plastic glue. It's sort of like a mixture of the two. So it's quite useful, not for gluing wood, but for doing jobs like that. I think that covers it all. Oh yeah, I was going to come back to this, right? These are the motor encoders. You've got power, ground, and then 2 signal lines. If you put power down these by accident, you will destroy it. It won't work anymore. So that plugs into this cable like that, just for convenience when you're assembling it. They plug together, but you have to plug it the right way round. So if you plug it the wrong way and put power down one of these green or wire, it won't work anymore. So I will test all of this at some point before I send it to you, and I'll also put labels, or maybe paint this side white, and I'll tape it together. You can't get, you really must not put it in backwards. No smoke will come out or anything, it just will fail to work. Now, in terms of the crank, basically, you could mount that, see it's got bolt holes in the end of your Organistrum, and attach a handle to it. This is a 6mm diameter shaft, and you can get joining connector things like this, or you can get so-called, hang on, find one, flanges. Here's a Here's a bag of a whole load of them, but you see these are actually 8mm, but these would slide on, do it with a grub screw, and then you can mount whatever you want onto that, which could be the handle. Problem with that then, if you do that, you'll have a working machine, but of course there's no friction. The handle will go around really easily. So the way my Gerdies actually work, there's a long shaft, there's a bearing this end, there's a bearing about halfway along, and then on the end of the shaft, using one of these flexible joiners, they've got a slight flex in them, it connects to this. This is held in place with a custom 3D printed bracket. Hang on, hang on, can't remember myself. Hang on, like that, sort of like that. Weird shaped thing, and it bolts down flat to a wooden panel there, so that holds it all in line. And then also slid onto that shaft is one of these things I just showed you, the 8mm diameter inner diameter flanges, because the shafts are precision ground rods which are 8mm in diameter, and then onto that flange is fitted, where is it, one of these. There's a 3D printed piece that goes in here that screws to that flange. That's the drum brake from a children's electric scooter, and I was buying these drum brake assemblies from Japan, from China. So as you turn the crank, you've got crank, bearing, crank's welded onto the end of a shaft, bearing. This, because it's on the flange, it gives you a bit of adjustability side to side because it's held in with a grub screw. Bearing, shaft continues, on the end of the shaft is mounted that. And see, that has minimal friction turning, you just have to turn it so it sends rotation speed to the computer. Now the reason I've got the drum brake is there's then a felt pad which is tensioned onto that. There's like a lever here, hinge this side, tensioned onto it. This side there's a cable with a little spring in it, and it goes to a guitar tuner. So as you tighten up the guitar tuner, it puts more force on the pad, and it gives the user just a bit of adjustable friction to simulate the friction of the strings rubbing on the what would have been the rubber wheel, the wooden wheel. So that's that. Now I can give you a bag of bits. I mean, you're going to have to fabricate mounts for the bearings. I can give you a shaft if you want with the S-shaped handle on the end. I mean, it's Gerdi sized. It's about that long. Whether you want a bigger one for yours, I don't know. I could give you the shaft without the crank handle on it, so you can fit your own. It's just steel. It's kind of up to you what you want. My lever with the felt on it, the only reason it's a kind of bizarre design is because it has to fit into the wooden casing of the hurdy-gurdy, which was designed earlier, so I was constrained in the available space. But in your case you'd have a lot more space. So I mean, you could have a wooden wheel with a felt pad pressing on it that's just been polished. So it's up to you what you want. So next thing then is I would load up software onto this and just check it works, because if I short out these pins, these connectors, I can test each button works even without anything soldered to the ends. I haven't got any of these at the minute. This one is a defective one, but I mean, I could get one in with my next batch of Gerdies and test that for you. And as you know, the DigiGerdi, when it's running in MIDI mode, it has this row of tiny buttons on the back, for selecting things in the menus. But one of the things you can do is go down in octaves, or actually fractions of octaves, down to very low notes. I know an Organ-Istrum is lower in pitch than a hurdy-gurdy, but I'm not sure by how much. But you can just keep going down. So I think that is what you need, but feel free to come back to me and we'll take it from there.